Hello, this is Cio Rodriguez again, continuing with this CISSP 2024 study guide. This is the second video of this class. Actually, the third. The first video was just an introduction to the CISSP. In the first video, we cover objective 1.1. Understand, adhere to, and promote professional ethics. If you have not watched that video, then please do so if you're going to follow along with this course, this class. In this second video, we are going to cover objective 1.2, understand and apply basic cybersecurity concepts, right? So we are going to talk about the CIA triad: confidentiality, integrity, and availability. But we will also add two very important concepts that you need to understand as basic cybersecurity concepts, which is authenticity and non-repudiation. So what we need to understand here is that at the center of everything, it's data. So ultimately, that's what we want to protect. That's the, our data is our information is our, one of our most important assets that we need to protect from cyber criminals, from errors, from insiders, right? From a catastrophe, a fire, a storm, etc. But the point is that we need to protect data, right? We need to protect it from confidentiality, right? From the integrity of the data and availability, which we will discuss in a second. But this picture represents, again, three of the most important concepts that anything that we do in IT and cybersecurity touches one of those pieces over there. Okay, so the CIA triad, as it is known, and by the way, the CIA has nothing to do with the Central Intelligence Agency. Confidentiality, integrity, and availability. They represent the fundamental objectives of information security. They provide a framework, if you want to call it, for understanding how to protect valuable data and ensure the proper functioning of information systems. And let's talk a little bit about each of this, right? So confidentiality is the principle that safeguards sensitive information from unauthorized disclosure. It ensures that only authorized users within a legitimate business need can access confidential data. Imagine, for example, a company's financial records. Strict confidentiality measures are in place to prevent unauthorized individuals, that is, hackers, competitors, even disgruntled employees from viewing this sensitive data, and also from employees that make a mistake, or employees that are not well trained and that, again, make a mistake because they probably don't know what they're doing. So confidentiality tried to protect the data from all those sources. And obviously, it could also be from anyone that is not meant to see something, right? So confidentiality protects that. Now, so how do we do that? What controls are in place? And again, it sounds simple, but it's a lot more complex than that. And we'll dive deep into all this concepts and controls during this class. But one of the main countermeasure for confidentiality is encryption. Encryption, access controls, like, for example, multi-factor authentication, role-based access control, data classification, and data masking are some essential security controls that enforce confidentiality. When it comes to encryption, there are many products and tools, but for example, Windows, most versions of Windows, well, not the home version, but most enterprise and professional versions of Windows, both the client version and the server versions of Windows comes with BitLocker, for example, which allows you to encrypt the entire content of your hard drive. So if you have a laptop, for example, it is very important if you go to Control Panel, right, and you look for BitLocker, it's important that you encrypt the entire hard drive, because if you lose your laptop, anyone can, there are tons of free programs on the internet that you can put on a USB drive or a DVD. You can boot up into any Windows and you can break the Windows password. So breaking the Windows password, if you are in possession of the device, in the case that, as I said, that somebody steals your laptop, so breaking that password is relatively easy. But if your hard drive is encrypted with BitLocker, that person, whoever that is, won't be able to access the data on that computer. So imagine, for example, a doctor or an executive or a bank or a government employee that has an a laptop with a lot of confidential data. So you can do that with BitLocker. There are many other products over there, but again, BitLocker is a great choice, and it already comes with the operating system. When you turn on BitLocker, the hard drive will look like this, right? And then obviously, once you turn it on, you can suspend it, you can turn it off. But the matter of the fact is that, again, encryption is one of the most important countermeasure to protect against losing a hard drive. So that BitLocker. Now, another forms of encryption, it's called EFS, the encrypting file system. This also comes with the operating system. So if you right click on any folder or file and you go to the properties of that, you could encrypt the contents to secure the data. So you could encrypt a file or a folder in Windows using EFS. So basically meaning that only the user with that logon credentials can access those files. Now, you gotta be careful, because if you encrypt a folder or a file at a company, an employee does this, and then that employee leaves the company for whatever reason, nobody will be able to access those files, right? Now, when you encrypt a file or a folder, you can create what is called recovery agent, which is like another person, maybe your manager or another employee, right? That would be able to decrypt those files in case that they need to be decrypted because you left the company or whatever the case may be, right? Another way of protecting confidentiality in Windows, it's, for example, using, let's say, NTFS permissions. So here is a folder. Let's say that I have, company data, company information over there, right? I can choose, who I give permission to. For example, I've chosen over here that, there is a group. It is recommended that you give permissions to files and folders using groups, not individual accounts. That's the Microsoft recommendation. So I have a security group called IT, which has a full access to that folder. I have another group called HR for the human resources that maybe need to have modified permission or whatever the case may be. But then I have domain users, which is basically every employee. Let's say that there is company data for them to be able to read, like company information or programs to install or whatever. So to that group of people, I only want them to be able to read. So actually, it's like read and execute, so that if there is an executable, they can install it over there. They can list folder contents, and again, so normally you need those three in order to be able to read a file in a folder. Nothing else. They won't be able to write to that folder. They won't be able to delete. They won't be able to do anything else, because those users, whatever the data that's in there, they're not supposed to do that. But other groups can have, either modified permission or full control or modified permission, depending on the case, depending on what kind of uh, permissions they need to do the job. The least privilege comes in, which we will talk about a lot in this class, where no one, it's supposed, should have more permission than what they need to do their job. Anyway, so but this is one way, just another example of how to protect against confidentiality. The second tenet of the CIA triad is integrity. This principle guarantees the accuracy and completeness of information throughout its life cycle. That is, the creation, the storage, the processing, and the transmission of data. It ensures that information is not altered or modified in an authorized or undetected manner. Think of a medical record. Maintaining its integrity is critical to ensure accurate diagnosis and treatment decisions. Or think about, for example, a public company. They are, let's say that Microsoft is going to have its public meeting, and they're going to disclose their financials, the quarter of the year. So they have this Excel file with all the numbers. Imagine, for example, that someone can go in and change those numbers, right? And then when the CEO of Microsoft reads this information, it's not accurate, it's not complete, it's not the true source of information. So that would be really, really bad. So what kind of security controls do we use for integrity? For integrity, we use hashing algorithms, digital signatures, checksums, and audit trails. Those are crucial controls for maintaining data integrity, among others. These mechanisms can detect any unauthorized changes to data, allowing for swift remediation. So again, really important to understand that. This is a web page that you can go in just to practice hashing and how it does. But for example, here I just type in the phrase "hello world," and this is the hash value of that. Okay, if I change anything on that file, anything, right, the hash value changes completely. Okay, and that's what, so let's say that you have a big file. We were talking about those, the financial information. You have a spreadsheet in Excel with all the information for the company. You can hash that file, create a hash, and if anyone changes even one single number, anything on that file, the hash value will change completely, and then you will know that the file was changed. So again, when it comes to integrity, the best way to make sure that a file has not changed is using a hashing algorithm. Imagine, for example, in computer forensics, let's say that there was a crime was committed, right? One of the first thing that is done is take the hard drive and create an image of the hard drive, and then hash the value of that image. If anyone changes anything on that hard drive, then the value will change, and then you will know that there is no integrity for that hard drive. Okay, so if we look at so here is the actually I have the file over here, or again, you can type anything over here. So I'm going to type the word test. Here is obviously I can choose different hashing algorithms. SHA-256, one of the most secure, most common nowadays. But let's say that I have, so this is the hash value. Now notice, look at this number, right? Notice what happens if I just type a single, I'm gonna put a dot here, right? Notice how this number changed completely, okay? So I know that somebody modified this word because the hashing value changed completely. Again, so that's, how hashing works. You could also, let's say that, so that's a great page, again, that you can use to practice hash. You could also use PowerShell, right, which comes with Windows. So let's say that I have a database, right, called MyDB on the C drive. I can say get dash file hash with PowerShell. And again, we'll talk more about PowerShell during this class, because PowerShell, it's a very popular tool for IT professionals, cybersecurity, but especially for cyber criminals, because it already comes with the Windows operating system. You can do a lot of stuff with PowerShell when it comes to cybersecurity. But anyway, so I can then get a file hash, and then later on, if I suspect anything changed, get a file hash again. And if those numbers are not the same, it basically means that that file was changed. So those are two examples of the for hashing. The third concept of the CIA Triad we're going to discuss is availability. Availability focuses on ensuring that authorized users can access information and systems when needed. It signifies that information systems are operational and functional during critical times, or not just during critical times, during business times, right? A bank's online systems exemplifies the importance of availability. Customer must be able to access their accounts and conduct transactions reliably, right? So what kind of security controls do we use for availability? Well, we use HA, or high availability, and disaster recovery of DR solutions, system backups, of course, redundancy of hardware and software, and capacity planning are just some of the key controls that promote availability. These measures help mitigate disruptions and ensure systems can recover quickly from outages. So HA, we could use load balancing, for example. So, let's say you shop at Amazon.com. That website on Amazon.com, it's behind a load balancer. And there are many web servers behind that. So if one of those servers goes down, you won't notice anything. Even in this case, obviously, this is an example with only 2 servers. So if the 2 servers go down, the website will be down. But in a case like, let's say, Amazon.com, one of those companies like that, they would have many web servers in the back end, and they would have some load balances software to handle the load, right? Another example would be using something called RAID, redundant array of independent disks. We'll talk more about this, but this is a RAID 5. Basically, each of these represents a hard drive in a server. If one of those hard drive goes down, it's bad, or something happens to it, then the system continue functioning, because everything that's in the hard drive, there are redundant copies that can be reproduced in these 2 drives over there. Obviously, if you only have 3 drives and 2 drives fail, then you're gonna be in trouble, but you could have more drives. But that's the idea, right? How you protect against this for availability. RAID 1 is a very popular in server, especially whenever you have the operating system. So if you have a server that has a RAID 1 configured, one of hard drives fail, these drives are like a mirror. One is a mirror of the other. So if one of the hard drives fails, then you will continue functioning. So that's the idea behind this resiliency, right? And when it comes to availability. All right. So that's it for uh, the CIA triad. There's some references over here that you could use if you want to learn more about this. Now, beyond the CIA triad that we just talked about, two other very important concepts are authenticity and non-repudiation, right? Um, Authenticity is the principle that verifies the legitimacy of the source of information. It ensures that information originates from the claim source and hasn't been fabricated or spoofed by a malicious actor. So when you receive a software update directly from the vendor's website, authenticity mechanisms confirms the legitimacy update and not malware disguised as an update. So what security controls do we use to protect against authenticity? We could use digital certificates, message authentication codes or MACs, and sender verification mechanisms are some of the controls that are employed to establish authenticity. These controls help prevent phishing attacks and ensure that you are interacting with the intended party. Especially today's with artificial intelligence programs like ChatGPT and many other, and misinformation in general. You can create audio, you can create videos that are not legitimate. So you can record the voice of a person, or you could create a video with a person saying anything. So it's going to be very difficult to know what is true and what is not. Actually, it is already very difficult to know what is authenticity. And in reality, this is one of the most difficult things, is to prove what is authentic, right? So that's why digital certificates and this kind of countermeasures are so important. The last concept that we are going to discuss in this section is non-repudiation, which is the principle that provides undeniable proof that a specific action was taken by a specific user. It prevents users from denying their actions later. Digital signatures and tamper-proof audit logs are prime examples of non-repudiation. They create an irrevocable record that a particular user performed a specific action. Security controls for non-repudiation include digital signatures again, non-repudiation services, and secure login practices are essential controls for achieving non-repudiation. These measures ensure accountability and help resolve disputes about who performed certain actions. Imagine a camera, for example, a video. As I said, nowadays it's tough because you could actually fake those videos, but still videos are a depending if you prove that the video is authentic, then videos are great ways of you know to prove non-repudiation. So if somebody commits a crime and there is a video and it has been verified that the video is authentic, then there's no way that you can say that it wasn't used. So, and it happens all the time in courts where people go, oh no, it wasn't me. And then when they show them the video, they just put their head down. Well, in computer crimes and all kinds of crimes, again, having a video of someone committing that crime is a really good way to prove non-repudiation. Anyway, so just remember that these security concepts are interconnected. So one doesn't exist without the other. A strong access controls contribute to both confidentiality and integrity. Encryption safeguards confidentiality, while digital signatures uphold both integrity and non-repudiation. A thorough understanding of these principles empowers you to evaluate an organization's security posture, identify vulnerabilities, and implement appropriate security controls to create a robust security framework. Also, for any security certification, whether it is the CISSP, the Security Plus, the CISA Plus, whatever, any security certification that you take, these fundamental concepts are kind of the framework that we will use. So almost everything that we talked about in the future in this class and any other cybersecurity class will touch upon these concepts that we have discussed here, right? So this is the end of this video. If you are planning, and I hope, to follow along with me in this class, well, I hope to see you next.